are going to see heart diseases diagnosis using artificial neural networks. Introduction. Heart disease is a fatal global disease causing death due to inadequate blood supply. Early and timely diagnosis is crucial for preventing further damage and saving life. And artificial neural networks are not meant to replace doctors but rather provide suggestions while human experts make final medical decisions. Neural networks excel in timely and accurate decisions, surpassing administrative activity and physician performance in urgent situations, which significantly impact patients and require prompt action. Objective of the project. The project uses deep learning Python algorithm to predict heart disease using coronary artery disease, arrhythmia, and sleep apnea datasets. The CAD dataset contains 13 attributes with disease value ranging from 0 to 4. 0 indicates disease not detected and 1, 2, 3, 4 are the stages of the disease. Arrhythmia dataset contains 280 attributes and 13 class values. 0 means disease not there and value 1 to 12 indicate presence of disease in stages from 1 to 12. Sleep apnea dataset contains 12 attributes with class values 0 and 1. 0 means disease not detected, 1 indicates presence of disease. The project utilizes various neural networks including recurrent neural networks, convolutional neural networks, artificial neural networks, and it uses k-nearest neighbor machine learning algorithm to train the model and predict the disease class. To execute this project, these are the requirements needed. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is upload dataset. Using this module, we will upload the CAD, arrhythmia, and sleep apnea datasets and apply necessary pre-processing steps and split the data into train and test sets. Train set is for training the model and validation set is for evaluating the performance. In the next modules, I have run RNN algorithm, run CNN algorithm, run ANN algorithm, run KNN algorithm. Using these modules, we will input the trained data to the deep learning algorithms and evaluate the performance of the model. The next module is upload test data and predict. Using this module, we will upload the test set which will not have the target variable and predict the disease stage for all 3 diseases. The last module is accuracy graph. Using this module, we will plot the accuracy of all the models to compare performance. Execution of the project. To execute this project, first we need to open the code folder. This is the dataset folder in which I have the required dataset. Open the dataset folder. In this folder, I have all 3 disease datasets. So, apnea dataset, in this dataset I have the target variable and apnea underscore test dataset doesn't have the target variable. The same applies to the other datasets also. So, in the dataset underscore information folder, in this folder I have dataset information, that is details about rows and columns and the details of from where the dataset is extracted from and the links to download the dataset. This is the Python main code file. This is the run.bat file. Instead of executing the project in command line interface, we have created the Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. Now click on Upload Dataset button. A dialog box will be opened. Select the dataset. I am selecting apnea and click on Open. It confirms that the dataset is loaded and the dataset length is 70. The total dataset is divided into train set and test set. The train set includes 56 records and test set includes 14 records. The number of columns present in this data is 12. Now click on Run RNN algorithm, Run CNN algorithm, Run ANN algorithm button and Run KNN algorithm button. So, in the text box we can see the accuracy scores of all these algorithms. Now click on Upload test data and predict. A dialog box will be opened. Select the test data and click on Open. So in the text box we can see the independent variables and the classifications according to these independent variables. 0 indicates that the disease is not present and 1 indicates that the disease is detected. Now click on accuracy graph. In this graph on x-axis I have the all these models accuracy, and we can see CNN, KNN and CNN are performing well. Close this graph and execute the same steps for the remaining datasets, that is Arrhythmia dataset and CAD dataset. This time I am doing it with Arrhythmia. Select the Arrhythmia dataset and click on open. We can see the total dataset length is 452. It has been split into train and test sets. Train set includes 361 records and test set includes 91 records, and the number of columns present in this data are 280. Now click on Run RNN, Run CNN, Run ANN and Run KNN algorithms button. In command line interface, we can see all model generation process for each layer of deep learning. So it will take a little time to get accuracy. And we can also see process details such as epoch number and accuracy of that epoch. So in this text box we can see the accuracy score of these algorithms. And now click on upload test data and predict. Select the arrhythmia_test and click on open. So we can see the independent variables, and for those independent variables the classifications will be predicted. If we scroll down, we can see the classifications for all the records. Now click on accuracy graph. On the x-axis, I have the accuracy, the names of all the models, and we can see ANN is performing well. Perform the same steps for CAD dataset now. Select CAD and click on open. We can see there are 303 records in the data, and this 303 is divided into train and test set. Train set includes 242 records and test set includes 61 records. Number of columns are 14. Now click on Run RNN algorithm, Run CNN algorithm, Run ANN algorithm and Run KNN algorithm buttons. So, in the text box, we can see the accuracy of by running the CAD dataset, and now click on Upload Test Data and Predict. Select CAD_test and click on Open. So we can see the classifications here. Now click on Accuracy Graph. We can see ANN is performing well. The conclusion here is the project uses deep learning Python algorithms to predict heart diseases, coronary heart disease, arrhythmia and sleep apnea using recurrent neural network, convolutional neural networks, artificial neural networks and k-nearest neighbor algorithms. The model predicts disease classes, enhancing patient care and reducing the risk of complications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.